Hello everyone. In our previous video when we covered functions, the examples given weren't of the variety that I'd like to provide. In this one, we'll be covering the quadratic formula and making it into a function. And what's interesting about this function and its implementation in this video is that it will have three inputs, which will be singular values, and there's a possibility that it could return one value, or it could return a list. This is something that's quite unheard of for those who have experience with C and C++. So let's get started. Because I'm going to be calculating the quadratic formula, I'm going to have to include our square root function from the previous video. Now that that's done, let's create our function. We can create our function with the def, or define, keyword, and we'll give it a name. I'll call it quad. It'll have three inputs, A, B, and C, which should look familiar for those who have studied the algorithm. Right, so when we begin, we need to calculate the determinant of the quadratic formula to make sure that it's not negative, because when we're calculating the roots, we only want to calculate them if they are not imaginary. So here I'll use the exponentiation math operator to help us out, and I'll subtract 4 times A times C. Right, so there's two possibilities with our determinant. It can either be greater than 0, which means that we will have real roots, or it can be less than 0, which it will have imaginary roots. And that is something that we do not want to deal with. And because we don't want to deal with imaginary roots, we will create an if statement that will let the user know that we will not be dealing with imaginary roots. And in this case, because we are letting the user know that the roots are imaginary, we don't want to do anything. We want to get out of here. So what I'll do is that I will return none. So here I'm going to be returning a singular value, which is none. And for those that don't remember, none is essentially the equivalent to null and the null pointer, for those who are familiar with C and C++. However, if our determinant is equal to 0 or greater than 0, we want to go ahead and calculate the quadratic formula. So I'll calculate the first root, which will be x1, as such. Something that I like to highlight is my use of parentheses. Here I like to be very, very in control of what kind of mathematical operations that I'm doing. Something about programming in math is that now when it comes to calculating mathematical statements in programming, it'll go left to right. It will try to obey PEMDAS, for those who remember the acronym. But if we have something like multiplication and division, it will go from left to right. So I use parentheses to focus more on the mathematical operations that I want done first. Right, and when these two roots are calculated, I'm going to create my result, and I'm going to set it equal to a list of these two values and return it. Return result. Right, and there's something groundbreaking here. The first thing is that there's two cases of outputs for this function. Either this function is going to return a list, or it's going to return none. And none is not a list. These are two completely different data types. And this is what is amazing about Python. is that I can do this and it can be totally valid. So why don't we put this to the test? Here I'm going to create 3 variables. And now I'm going to call my function and store it in a variable called roots. So I want to check either if the result is correct and it returned a list, or if it's null. So I will use an if statement to check if roots is valid. So if it's not null, if it's not none. So if it's not none, I just want to print the roots. And, well, why don't we run this and see what happens? Okay, so for those that don't know, these are the roots of this function. However, I do encourage you to go figure this out for yourself and confirm my results. So if we're able to find results with this function call, well, this means that we returned the list. So we've covered half of the possible scenarios of what this function could return. So why don't we change z to be equal to 50 instead of 5? And let's repeat the process again, and let's see what happens. Uh-oh. Here our determinant was way too big and it was less than 0, and our function caught that. It says roots cannot be imaginary, so it returned none. Because roots became none, this if statement is false, so this is never executed. Not too bad. I hope this shows the versatility of functions in Python. See you in the next video. Thanks.